Hope you're able to hear me. All right. So, good morning, everyone. And once again, I would like to thank VIT Chennai for inviting me back. All right, and Jai ma'am for inviting for this session. Right. I hope you all belong to which year. I know you're okay, MTech Integrated Business Analytics. All right. Before I begin the session, can I have your answers on the chat? How are you all doing today? How you are all doing today? A word answer on the chat. Good. Just now morning session has begun. Yeah, it's a bright morning session. All right. I hope others also to give just one word on the chat. Mics on mute, please. Maybe the host can put the mics on mute. All right. Now, let me share my screen with you. You're able to see in my screen? Thank you. So, today we are going to see about what are the different applications of machine learning. There are several applications, particularly with NLP, from chatbots to Gen AI, right? So I'm Dr. Doreen Robin, the founder and director of Computational Intelligence Research Foundation, Chennai. And our website is www.cirf.co.in. It's a Section 8 company. We have registered under Ministry of Corporate Affairs, Government of India. We particularly work on four pillars. One is research, the second pillar is development, the third pillar is education, and fourth pillar is training. All right, so you can visit our websites to know. For the student specific domains, we provide internships and in-plant trainings for industrial visits for the students and also collaborating with us for paper publication. We train you and you will be writing papers publication on your own. All right. Can you find some mistakes on this picture? I'll give you 15 seconds. Quick, please. Either unmute your mic and speak or answers on chat. What is the mistake that you find on this picture? Quick. Yeah, it's 15 seconds are over. Anyone? Mm-hmm. You were not able to find any mistakes? Hello, you're there with me? Yeah. I'm getting response from Chandra Kiran. What about your faculty or staff, student? I'm not sure. All right, all right. Only from Chandra Kiran I'm getting. What about others? You're not able to find a mistake? Yes or no? Yeah, there's a cookie on the stethoscope. Thank you, Tanveer. Others? There's two more mistakes. Anyone? I want you all to have a try. You're all brilliant students, right? How many years is MTech integrated? 5 years. So you have got one more year to go. I don't know whether Chandra Kiran is the class representative. I'm getting all the answers from him. What about others? All right. See, the one mistake is there's a cookie here on the stethoscope. The colors of the socks are different, and others are different animals, and we have a dinosaur here. I'm going to give you one more chance. I want this time the answers to be really, really, really quick. Find out the mistakes from this picture. Quick, please. You can unmute. Thank you. Thank you, Naveen. Exactly right. There are two more mistakes. Quick, please. Others? There are so many of you. I've heard voices of Tanvir, Chandrakaran, and Naveen. What about others? Anyone others could give a try? Mm-hmm. No? What about the girls? All right. The next other mistakes are this actually the cement road is dry, it's not wet. And the third is he has had the spectacles on backward. So now we are able to understand. See, if we're able to find the facts, which means you need to understand the fact. Without fact, we'll not be able to find out the mistakes, right? We will not be able to find out the mistakes here. All right. And so now we move on to the main session. So, what do you understand from your perspective NLP, machine learning, Gen AI, chatbot? The four words each of you can say the answer or on the chat. Quick, please. I want to focus you on four words: machine learning, NLP, chatbot, generative AI. From your understanding, yes, please. Am I audible? Yeah. From your perspective, I want four of you to give me an answer. What is your understanding of NLP? The second one is machine learning. The third is chatbot. The fourth is generative AI. You could be right, you could be wrong. There is nothing called right and wrong. From your understanding, maybe a single sentence. Quick, please. All right. Thank you, Vidyashri. That's an excellent answer. Others, could you have a try? Yes, please. Any one or two? If you have, yeah, very well said. How a machine can understand from the data. Basically, we speak about data patterns and how that could be improved. Yes or no? This is what we have been playing on the two games, right? Finding the mistakes, right? Very important is to know the facts. The facts comes from your knowledge and understanding. And how do you apply onto it? So knew about bread, but you can understand bread cannot be a brick. That's what immediately you're able to give an answer. Here you start from your knowledge, your understanding, to your application and your synthesis. Able to understand, that's what we played. See, you know a cookie cannot be in a stethoscope. All right. So now we are able to figure it out, right? Because you know the fact. Same thing happens in machine learning. You make the machine to understand the data, all right, and try to learn the data patterns. And from which either you go for classification or clustering or regression and so much and so more. All right. Anyone would you like to add on to it? Anyone would you like to add on to it? Yes, no, no, yes. All right, let's move on. So, NLP, it stands for Natural Language Processing. So, for example, at CIRF, we give them like sometimes on 15 days training with internship, 30 days training. Like even students from VIT has come for 3 months, 6 months, and so much and so more. One such student really did a very, he's from one of the engineering college in Chennai, right? We taught him about natural language processing, right? And he's a first year student, very basic concepts, and he was more interested. And then he developed an application, a very simple web page, where you can. He's just first year, right? When you can type in a sentence, it gives the translation of that into 32 languages. All right, that's one thing in it. The second thing, you can speak through speech as you speak through as Alexa, Google Assistant, and that converts to the language and then it translates, right? So, natural language, as Vidya said, you speak in your language and make the system to understand and compute the task that is required for you. So, when you say NLP, it's a branch of AI, right? In AI, the subset of AI is machine learning, the subset of machine learning is deep learning. All right. When you take all right, and then you'll be able to interact with computers and human machine languages, not human machine, human languages. So which makes very quick, when you see, I don't know whether you have used YouTube when you're very very small, but nowadays kids, right, when they start using YouTube, or if they want to see a video, you see, naturally they go to what do I say? Naturally, they go to the YouTube. Knowingly or not, unknowingly, they press the mic and then they speak and they ask what rhymes they want or what cartoon they want to see. Yes or no? Which means, that's the greatest application of natural language processing, where it is very much easy and flexible for people to read, understand, and interpret and generate human languages. Yeah, Siri, it gives you answer. Even if you use ChatGPT, most of you use ChatGPT. And Gemini also works with that, right? Also works with that. So now, if you combine linguistics, machine learning, and computer sciences, right? So when you come into computers, they understand how, like how humans they do work. So what are the basic tasks of natural language? In today's session, I'll be starting with NLP, the process of NLP, the machine learning. I'll show you a demonstration, and at the end of the session, we'll play a live quiz, and we will see who will be the winner of the day. All right. So when you take natural language processing, it is a process through which AI is taught to understand the rules and syntax of languages. Right. So, and it's programmed to develop complex algorithms to represent and those to carry out specific tasks. You can use it for language generation. I said, right, one of our students, his work was really, really beautiful to look at. Right. Answering questions, chatbots, right? Text classification, how you classify the text, sentimental analysis, right? And I'm going to show you in a demonstration of sentimental analysis and machine translation, right? When you see to it, very simple example that you can see, you all use Google Docs, yes or no? Do you use Google Docs? Yes. So here you have a tool, and it's a very simple tool, because when I train faculties, I teach them about they need to generate a lot of content, right? So as I'm teaching, if you now even YouTube gives you the transcripts. Otherwise, I can also do like that. So what we are going to teach, it is going to naturally convert my speech to text, and it can be processed, right? Speech to text, and it can be processed. So this can be very much useful. You can see the speed in which it translates my speech to text. All right, it translates my speech to text, and how this could be used, right, for many many purposes. And also you can have this on when your teachers are taking the lectures, and where you can have it as a recording of it, right? And this is one such example. Right, moving on to this. And what are the applications of natural language processing? What are the applications of natural language processing? By and large, if you're going to see to it, all right, and it starts with the language translation. I'm not very sure if I could find that. It's a very simple line of code, and I was so amazed how creative the student was able to do the translation of learning basics of Python. That's to a first year student, and how he was able to convert that into different languages, right? Different languages. And also you can use for smart assistants, right? Like use Alexa, Siri, document analysis, right? You can do a lot of analysis on documents and what is the document speaking. By and large, I see that the lawyers, right, they work with huge volumes of data. If you expertise yourself in NLP and developing your own applications, all right, how like a chat gpt is an application, Gemini is an application. Now you're in fourth year, so you can plan yourself to develop an application where it processes a document. And there's a huge opportunity for computer science people to work under a lawyer or in the law department, where they work with huge volumes of data. So when a case comes, the system already has a different clause, but already I say it cannot replace humans, right? This cannot replace humans, but it will be giving you the first level of analysis how this case could be handled, whether the case will win or not, what is the authenticity, how are the different ways when a client comes, what are the different ways that he could be helped out, right? Helped out in handling this. And online searches, Google, Amazon, they do a plentiful research onto it. How many of you use Amazon? Can you click raise hands? Yes, most of it is Amazon. Nowadays, when you use Amazon, can you see when you go to the review part? When you go into the review part, if you're having a mobile, also you can see. You choose a product and go on to the review. Now you can see there are certain. It takes the synthesis of the review, all right, and shows about it, right, and shows about what other people have spoken about it. I don't know whether you have tried it, right? And that plays a really a vital role, right? Really a vital role. See, I can show you. See, I've taken Amazon. I hope my screen is seen to you. All right. Can you see here? In general, you'll be having reviews like that. I've recently upgraded, so you'll have so much of reviews. But this is the text given by the customers. All right. But you don't have time to go through all the reviews. But here, this is what can you see here? Generated AI, Amazon AI generated text from generated from the text of customers reviews. So here is where your natural language processing works. Years back in 2018, there was a student in at CIRF. She worked with almost 100,000 of reviews, and she generated stats like you see, like 5 star, 4 star, and we got almost 87 to 90% clear. And she worked with analysis and also with Hadoop. I don't know whether you would have sure you should have learned about Hadoop on big data analysis. Now you can you see customer praise the iPhone's rock solid build quality, amazing battery life, and so much and so on. All right, can you see? And sometimes some finds it's very expensive. This is where you're being a computer science professional. Your majority job is not to find how the customers, how you can develop a product on your own, right? So can you see this is what that student she worked. See, 77% has given a 5 star rating. All right, and coming back, so that's about online suggest predictive text. A predictive text sometimes when you type on your mails, right? When you compose on your mails, and this itself will tell you what is that the next thing that you need to get it, right? So if I'm going to type greetings, and then I accept something if I give, and it gives the ending of the uh, it itself is, it will giving the ending, right? I'm just typing in. I'm not typing invitation, but it is give. Can you see when I keep a tab, you get it? All right. So this comes your predictive test. This comes your predictive text and automatic summarization. That's what I showed you, a very good example of Amazon and how it works, right? From the reviews. Social media monitoring, right? It does lot like 1 year back photos, 2 year back photos, how many people have reviewed it, and chatbots. I know. What can you give me some examples of chatbots that you have been using? Yes, please. Chatbots. I want you to interact. I want you to share. Any product? ChatGPT is a very good example. What are the others? I'll give you 2 minutes time. Can you search and let me know? ChatGPT uses large language model, which is a part of a specific type of NLP. What are the other examples? Mm, yes, then. Unknown caller. Yes, please. I'll give you 2 minutes time. You can search and post the products or application on the chat, please. I'm waiting for your answers. NLP chatbots. Quick, please. Yes. Customer support bots. Lot of websites you have. Yes. I want like specific products. You can Google search and also and let me know. Yes, Siri, Alexa. Well said, Dhanush. Others. Others are you all connected, please? Yeah, it's by Samsung. IBM Watson. Well said. Well said, Vidya. Dialog flow from, yeah. Others, I'll wait still for a few minutes. You can Google search it. And or you can ask ChatGPT or Gemini. Just I want some products, but don't repeat what others have said. Mm-hmm. All right. All right, and then today we'll be about seeing sentiment analysis and email filtering. Email filtering, you itself would have seen to it, right? It itself filter as inbox, or it sees whether it is a spam mail or not a spam mail. All right, and how do you do it? Like promotions mail, yes or no? This is one example. You can manage labels, or the application itself will find whether it is a spam mail or a not spam mail. If it is spam, it goes to it. If it is not a spam, it comes to your inbox. This is a very simple example of, see, it is not examples. I want you to rethink and process in your mind. All right, how you can develop an application like that could figure out, that could fit on to any one of this application. So when you take natural language processing, have you done projects with NLPs? Have you done projects with NLP? Okay, what is the process, or what are the mechanisms that you followed? Okay. All right. I told you NLP is a branch of AI, and ML is also a subset of AI, where we tokenize your words and named entity recognition and a sentimental whether it is positive or negative or neutral. I'll be showing you an example at the end of this session. I'll be showing an example of integrating both natural language processing and machine learning. All right, both natural language processing and machine learning. In machine learning, I'm going to work with supervised because my target, whether they are positive sentiment or negative sentiment, it's about a skincare review analysis. All right, and unsupervised, it works with clustering mechanisms. You don't have anything like specific targets, and also you can work with deep learning. All right, deep learning is a subset of machine learning. ML is a subset of AI, and DL is a subset of ML. All right, and one branch out is not. So today we are going to see about both NLP and machine learning together, and how that could be applied, through which how can you develop your applications. So before a machine can carry out any of the tasks, first it has to understand the language. See, I'm speaking in a language English, wherein you're also able to understand that language. All right, and by and large, when you see to it, this is what is done by machine language, right? So where you give huge volumes of data, and ChatGPT, we are only giving a lot of data to train. When you use more ChatGPT, you are giving the data. More is the training data, the more is the accuracy, because it is trying to get more information. How NLP works? First, a human talks to the machine. It captures the audio. Sorry, the audio is converted to the text. The machine processes it, and data to audio conversion occurs, and the machine responds to an audio. And in Google Docs that I showed you, it starts a human talks to the machine captures audio. So your Google Docs application stops here, all right, for the specific application, audio to text. So for here in this application, I'm a human, I'm speaking to the machine, and the machine captures my audio and converts to text, and the text is displayed. And here, if you find any mistakes, then you could change it accordingly. All right. So I said any mistakes so that you can do it. But these are different stages. So how it works? Your data. Your computer has a huge volume of data. Human labels this data with the rules and teaches the syntax, the semantics of the language, and you've got algorithms that forms the basis of your language model, right? ChatGPT uses large language model, which is a type of natural language processing. Right. I'm going to give you a minute or so to find what is the model used by ChatGPT and what is the model used by Gemini, because it also works with natural language processing, right? Quickly, the specific model. Quick, please. Quick. I want everybody to search and give me the machine learning model used by ChatGPT and Gemini. Specific model. Fast, please. Mm-hmm. Gemini uses transformer based models in Gemini. Yes, correct. Then any other suggestions? What is LLM? Large language model. Can you find out the specific LLMs ChatGPT uses? ChatGPT uses the LLMs and Gemini uses the multimodal large language model. You found it out? Yes, no? All right. So this is very important. So both uses and creates and to inform large language models, right? Large language models. Both uses LLMs. So you can see on to your Wikipedia what is a large language model, right? So when you see it's a language model with self-supervised machine learning that is designed specifically for natural language processing. Able to understand as you're learning this paper, you need to understand more. So the large and most capable LMs are GPTs, a transformer, that is what is used in Chat GPT, Gemini, and Cloud. All right. See, there are certain Gen AI tools where you give a text, you can have a comparison of Chat GPT, Gemini, Cloud, and so much and so more. Have you seen about it? Yes or no? If not, I can show you a demonstration. All right. So it is used for prompt engineering and you're able to hear me. Okay, I think the networks. All right, and also you work with ontology, right? So ontology, when you say, have you heard about ontology? Sorry. Have you heard about ontology? Okay, when you're going to work with natural language processing, we speak about the rules and the syntax. Very specifically, need to know about the semantics and ontologies. Right? When you say ontology, it's about finding the relationship, the semantic relationships. Can you see the diagram? There's a beautiful tool called Proteach. I can also show you the tool, and it is developed by Stanford. All right, and it's a free open source ontology editor where you get an ontology the visualization when you give your content and it finds a semantic relationship between the entities. All right, I strongly encourage you to learn these tools, or yeah, we also give a lot of trainings on this tool, and this plays a vital role in NLP too. All right, that's what you can see about ontologies here. All right. So they say about supervised learning, the dimension reduction, anomaly, and so much and so more. I'm not going much into it. Let me come. So where you're going to tokenize, where the text is broken. Have you heard about when you are in your grade 12, a subject, verb, object? You have learned in English grammar. Do you remember that? Yeah. So here it works with the same thing, right? So how do you analyze your sentence, right? And synactic phrases, right? So you find the subject, the object, the verb. So tokenizing where the text is broken into smaller semantic units. And then you have your parts of speech tagging. First, you have your text. You make your text into, so for that semantic relationship, the ontology plays a vital role, and it's very. And I personally feel it's very important for you all to understand, to know the tool how it works, right? And here you classify it as a noun or a pronoun or a verb or an adjective or an adverb or accordingly, and then you go into the stemming, right? So where words are reduced to the base or roots, right? Some the words that is not of much needed, that will be removed, and only you reduce to the base, where AI looks like stylish patterns in conversations, right? So when you take about the NLP tasks, right? The tokenizing, named entity recognition, the part of speech tagging, we call it as lemmatization or stemming, word sense ambiguation, and keyword extraction. These all works in your word tagging. That's very important. You've got different Python packages to work on. Sentence parsing. constituency, semantic labeling, dependency parsing, co-referencing, and clause boundary detection. So text classification. Today we are going to see about the sentimental analysis and intent detection, topic classification, fake news, right? Email classification and customer feedbacks, right? Customer feedback analysis. So text generation. That's what your chat GPT, generative text modeling, machine translation, summarization, personalized dialogue systems, report generation, and question answering. Text pair matching, semantic textual similarities, natural language inference, and relational extraction. Now let's listen to the application of natural language. So, so you have you're able to all right. So, uh, text. All right. So let's move on to machine learning, right? I said it's a subset of artificial intelligence. All right. And here you enable the system to learn from the data, right? Already we have discussed about different applications, right? From the applications of the different algorithms works on with, right? Every part of your NLP and machine language involves a lot of algorithms to work, right? Your input is your text, and how you're going to process it, how you make the function to compute it, and how do you find the accuracy of the applications, right? So the computer learns from the data and make predictions, and you find the data patterns and improving the performance based on data. I always say the key word for machine learning and deep learning is data patterns, discovering your data patterns. The better you discover your data patterns, the better or best is your algorithm. All right. So even in your college, now you're in your fourth year. All right. How many of you have got close friends in your college? Maybe in the same class. Do you have close friends? Yes or no? Type Y or N. Chandra Kiran. Yes. Yes, Vidya. Yes or no? Type on the chat. Do you have a close friend? Or at least you have a friend? Y or N? Yes, please. I'm not able to. Yeah. Yes, you all got difference, right? Do you have whether you're able to find your friend on your first day on first day at college? No, you have got a lot of past experience. You try to spend time with them. You try to like their character. You try to like their behavior. Those you don't like, you say you keep them as a distance. Whom you like the most, then you keep them close, and then you share and you care for them, and you love them, and also they do the same, right? It takes timeline to figure out your friend. Yes, the same thing here. Your brain tries to learn the behavioral patterns, and you find who will fit for us, who could be my friend, who cannot be my friend. All right. And same thing works here. But here you can process with less, maybe less than five friends you have. You cannot work with 100,000 friends, right? Maybe we have a lot of followers on a social media, but they are not true. They don't try to know, you don't try to know more about that. But machines can process huge volumes of data. I always say AI is everything, like machine learning, deep learning. Only thing that AI is different from human. I strongly believe humans, we have common sense that is not available in AI. All right. So coming to machine learning, you have a lot of recommendation. I showed you, right? So when you see in Amazon, it also shows if you select, probably I'm just selecting a product, and then it says what are the different varieties, and it says about the different offers, and also it does a lot of recommendations when you come down, which will be good for you, and it says customer who viewed this product has also viewed this product. Have you seen somewhere? You can compare with the other products. It's not comparison. You can see customer who viewed this product has also viewed the other products. So from which you will be able to it will give you other recommendations, right? It will give you, that's a recommendation. In YouTube you get a lot of recommendations. If you see a video, then the concurring videos you can see to it. Netflix, right? Spam filters in Gmails, fraud detection and credit cards, and other services, automatic quality control, and manufacturing industry, especially in automobile industry. Um, it really works a lot, right? It really works a lot. And here, when you take supervised learning, you have a target. For example, in the exam, you pass or fail. The person is diabetes or not. Yes, so you will get the admissions or you don't get an admission, always with the target. Say for example, somebody, if you want to develop with cancer diagnosis, no cancer, level 1 cancer, level 2 or level 3 cancers, that's multi-classification. Anytime you have a target, it is classification. All right, regression is where you work with continuously changing variables like gold price, the stock predictions, the drug responses. Unsupervised, it's only clustering. You cluster the data, you don't have whenever there is no target, then you work with unsupervised learning. For example, you all go to malls. Do you all go to mall? Yes or no? You're all from Chennai, right? What are the malls in Chennai you have visited? What are the malls? Phoenix. All right. Others? Hmm? Express Avenue, VR Mall, right? Empire Skywalk, Marina Mall. Why do you go to malls? For window shopping, okay. Others also can put. Why do you go to malls? Go for window shopping, you go for movie, you go for food. During summer, you go to get a free AC. Yes or no? Otherwise, simply going to chit chatting with friends and spending time and coming back. Yes or no? So where you don't have a specific target, all right, but for those kind of application you use clustering. For those kind of application we use clustering. All right. Then it's a reinforcement. What is reinforcement? I don't know whether it works now, but when you were small, maybe your parents would say, if you get good marks, I'll get this for you. If you do this, I will do that for you. They're trying to give a reward, right? Some children, because they will be getting a reward, they try to do those things. So using a reward system is what is a reinforcement learning. All right. So these are about, so now coming to the basics of text processing in the first step. So, how do you convert into clean, structured, machine readable form? That's very important. Once you do that, then you go into sentiment analysis, then you go for your machine learning models. So, very first step, if you want, you can make a note of it. First is tokenizing, then text removal. What is the unwanted text that is not needed that you'll be removing, and then lemmatization, and next is parts of speech tagging. If you want, you can make a note of it or take a picture of it. Right? First, you tokenize it and remove unwanted words or special characters or punctuation or stop words. All right, and then you go for stemming. More advanced concept of stemming is only lemmatization and parts of speech tag. All right. So, for say for example, how do you tokenize it? You split your text into smaller units called tokens, words, sentence, or subwords. All right. I love NLP. So I, comma love, comma NLP. Splitting paragraphs to sentence and sentence tokenization. In sub-characters or character, breaking words into characters or subparts that is used in BERT and GPTs, right? Then next is stop word removal. So removing of common words like is, the, a, and, in, of, to that reduces noises. The book is on the table. After stop words, you have the book, comma, table. So for example, if I'm going to take the cat eats the mouse, how can I open bank account with you? Cat eats mouse. Open bank account. Can you see to it? Removing your stop words. Next, that's your first tokenization and removing of stop words. Third step is stemming and lemmatization. You reduce words to their roots or base. Sometimes it not may not be a variable. Playing is played, plays, play. All right. So these all I'm going to stem it to play, but study, study. It is not right. Rule based faster, but it's less accurate. So generous, gener, fairly, fairly. It is abruptly cutting, stemming, but here it uses a vocabulary of finding out generous, fairly, sings and changing. So you're able to words into dictionary or post base. So better is good, studies is study. So stemming is fast and rough cut, whereas lemmatization is slow, but it's always linguistically correct. Then how do you convert from your raw text to numbers to your machine learning algorithms? Whether you're able to understand till now, okay, others, only a few are active, okay. So now you have to represent with bags of words or called as vectors of words. So for example, that where you find the frequency of words. So for example, cat, cute, dog, small. And the first thing I have small and dog. The second sentence I have cat twice and the cute twice and cat once and cute once and dog once. So I love NLP. I love machine language. So and then you can add both, and now you go for a TF, uh, terminal term frequency and inverse document frequencies, right? Term frequency and inverse document frequencies. Here you give weight to words on their importance, right? About their importance. So across the documents get lower weights like the, but more so TF term frequency inverse document frequency, right? So, and the next step where we go on word embedding, right? You go on to word embedding. How do you go up with word embedding? So first we started with bag of words, TF-IDF, and then the next step is word embedding. So from dense vector and continuous space, right? And then you'll be capturing the semantic relationship here. Only the proteage ontology plays a vital role. Bag of words, like embedding, works with context and relationships, right? Context and relationship. King man plus woman queen, Paris, France, Italy, Rome. So Google predicts words in context, and Stanford uses word occurrence statistics, right? You can see to it. These are the two popular models. So in today, I'm going to show you about this. Have you worked with Bander Sentimental? Bander Sentimental. Have you worked with Bander Sentimental? Yes or no? Yes or no? Okay, so I think these components you have used, right? Importing NumPy, SNP, Pandas, Matplotlib, and Seaborn. And I'm going to use the model selection for train test split. I hope you should, oops, you should have worked with machine learning algorithms. And then how do you extract the feature or extraction? So the count vectors, right? So feature extraction for machine learning, I'll be using multi-nominal naive Bayes and classification report. So I'm going to for RE package and NLTK, so Natural Language Toolkit package. I told we have to, you remember, after tokenizing, we need to remove the stop words. So that in NLTK.corpus, I'm going to import stop words, and NLTK itself has got its stop words, and I download kit. And how do you tokenize and do the stemming? Python has got its own tokenizing in NLTK and Porter stemmer. There are different methods. I'm going to use these for the days for today's session. Is it clear? Till now, any doubts? So I'm going to use this review. This is about a skincare, right? The review title they give perfect. You need this clean. This explorates review title, the review text, verified buyer, review date, right? Location, upwards, downwards. What is the product is all about? What brand and what is the scrap date? So I've taken almost 4,146 data and 12 columns. Right, I'm going to describe. So I've got how many count of upwards, downwards, right? And here I've got mostly in object. In object, it is strings, all right? And then only these two are integers. So from this, I'm going to take this particular, hope my screen is seen, ma? Yes? All right. So I'm going to give it as product. All right. I'm going to see how many products. This is in pandas method. So there are one, two, three, and four products. All right. And what is the brand? Mostly it's the same brand. And what are the scrap dates on a particular date? So I'm going to do a count plot using Cbond, having the products. I told, right, we have four products. And what is the count of the products? So I can see daily microfoliant is more and almost with superfoliant, and hydro and multivitamin is less. So I'm going to group by upwards, right? How many of them have given upwards? Mostly for microfoliant and very less for hydromasculate exfoliant. All right. Now with downwards, again it's for microfoliant and accordingly. All right. So how many of you have got verified buyer? Verified buyer is very less. Unverified buyer, non-verified buyer, they are more. Now I told we have to tokenize it and remove the stop words or words that has got regular expression. So removing HTML tags, I'm going to use RE, and to clean it, caps lock backslash. All right. So removing the URLs and punctuations. And now I'm installing NLTK. I'm downloading the stop words from the corpus. All right. And word. And also I'm going to install emojis, all right, to remove emojis from my content. Nowadays the new Gen Z and Gen Alpha, you use lot of emojis even on a simple WhatsApp, right? So de-emojize, and then we go for tokenizing, word tokenizing and sentence tokenizing. So using Spacey, I'm going to tokenize it using Spacey. All right, I'm going to tokenize it using Spacey, and then port stemming. I told, right, we'll be working with stemming. All right, and in stemming, I'm using port stemming. Only the stemmed words that we take, and then so these all are definitions. Can you see? Def is a function. Def. I've given all as a functions. Now I'm going to give my entire data set, that is my data frame here, and I'm going to copy it to DF, and then I'm going to make it as lowercase, remove punctuation, remove stop words, de-emojize, word tokenize, and lemmantize your words. Once that is done, I get my data here. X pre-process input, and then you can see to it how the words have been done here, and then you import your collections, right? Import your collections. The what is more, because it is skincare, you can see a lot on frequency on skin, right? And then I can generate word cloud. Have you worked with word cloud before? Yes, no? So which word has got more number of occurrence will have the greater font, right? Skin, love, all right. And now you can see I'm going to start with your name based multinomial name. So I'm pre-processing it. I'm using my Pankaj tab, all right. And then I'm reviewing my text to lower, resub, and tokenize. And then I'm getting my content like this into one column. Now you are able to understand how the sentence has been tokenized, stemming, removing of words, all right. And then I'm removing the stop words. Here I have the stop words. Now I'm removing the stop words here. Now I'm going to use the stemmer. Can you able to understand the step-by-step operations here? Yes. And then once everything is done, I'm going to use my sentimentalize using Badder sentiment, right? So I'm going to use import Badder sentiment, and Badder.lexicon I'm using here, and then I'm going to use my sentimental intensity analyzer. And what is the polarity? Either a positive or a negative. And I've given my data set here, and I find the apply the scores here, right? Whether they are pos, can you see? From the scores, I'm going to take whether they are positive or negative. So I see one more and zero less, 640. So I find more positive reviews here out of this 4,000, and negatives are 640. Can you see here? 84.6% positive, and I'm plotting it as a pie chart here from the natural language processing analysis. And then I go for counter vectorization. You remember I spoke about bag of words, right? And I'm going to transform it. It counts the number of vectors. Then I'm going to split it into train test, because I have my target here. What is my target here? Sentiment, either it is 0 is negative and 1 is positive sentiment. Because the data are so imbalanced here, I'm using smooth, right? Smooth to balance imbalanced data to be balanced data. And I'm applying multinomial naive based algorithm, and I'm going using my fits, and then I'm going to predict it. And when I went into my accuracy, I'm getting 85% of accuracy here, approximately 86. All right, I'm computing my confusion matrix. True positive, true negative, false positive, and false negative. And the same thing, I'm showing it as a confusion matrix as a picture. So this is where how you apply your NLP into your machine learning. Able to understand? So what are the challenges that you find here? Ambiguities has multiple interpretations. Say for example, if you take apple, it is going to be iPhone, apple, or a fruit, right? They stuck between. That's what you want to work with, semantic meanings, like synonyms. Each word can have multiple different words, same meanings or similar meanings. A polysemy, a single word with many related meanings, right? So a paper could be a writing material, or it could be an academic article, right? Movie, film, they means the same in context understanding, right? So rule-based methods may fail, but ML and deep learning captures it very effectively. That is what we integrate NLP with machine learning or deep learning. All right. So here we have already seen about supervised learning, classification, regression, and unsupervised dimensional reduction and clustering. And this is how I showed you a demonstration. How do you work NLP on with sentimental analysis? Any questions you can ask? The different pre-trained models, you can figure it out. You can work with personalized patient expression, telemedicine integration, health management tools, right? Data security, and eco-friendly sustainable gamifications, AI-powered smart healthcare, multi-language, token seamless insurance. All right. For fine-tuning of sentimental analysis, the pre-trained model is BERT. For customer support, it's GPT. That's what we use, Chat GPT. All right. And then T5 for document summarization. Any doubts? Any doubts till now? We've almost come to the end. I showed you, and we work with, I showed you the demonstration with WADR, WADR sentimental analysis. It's lexicon based analysis and rule based sentimental. So you can take data from any social media, Instagram, and then you can try to work. In today's session, I worked with the positive and negative. You can also work with neutral. So the battery, first you tokenize it, removing the words, and then you go for word count, and then you go for the stemming operations after removal. Any questions? Okay, let's play a game. You can all open slido.com and then give the score. And you can join. Just give slido.com. No need to download. Just give your name and this code. Let me see how many of you are joining. I can see Chandrakaran joined. Only two of you have joined. Others are joining. Any questions you can ask on the chat. Others join quick, please. We were almost 40, 50, and now. Shall we begin? Whether others are joining? Okay, you can give your answers. Which algorithm is commonly used for sentimental analysis? Most of you have given the right answer, and the right answer is logistic. First is Avi, I don't know what's the name. Second is Chandrakaran, third is Naveen, and fourth is Smiti, and fifth is Janani. Let's move on to the next question, quick for the day. What is the purpose of stop word removal? All right, to remove common words. Again, it's Avi, Naveen, and Chandra, and Smita. Others also can join. The code is almost on to your left. Only 9 have joined. Which step is not part of typical chatbot pipeline? All right. Image classification, right answer. Let's move on to the fourth question. Which of the following describes generative AI? Yes, 100% right. Because you're using it almost every day. Avi, I know what's Avi. Can you give your full name? Naveen and Chandran, the final question that describes who's the winner of the day. All right. It is the following is an example of reinforced learning. Uh, Training a robot to play chess. And the winner is Avi. I know what's your full name. And second place goes to Naveen. Third is Chandra. And fourth is Smita. And fifth is Divya Darshini. Congratulations. And if you want my contact, you can scan to it and get it. All right. And you can scan this, or I'll give this a link where you can give your comments about the session. Three key learnings of the session. Quickly, I've given the link also on the chat. Your name, your college name, your year of study, one line about the session. During which any questions you have. All right, this is my contact details. You can visit website and contact us through email. And this session is also live streamed. I'm giving my channel and other links, Facebook and Instagram and LinkedIn. You can follow it up if you wish. Thank you. Over to the organizers. Yes, please.
Yes, please. Yes, please.
Yeah, even if you take the retro pictures, it is we who are feeding the data into it. All right, and AI as enlarged. That's what we need to apply. We should know what is the fact. And there are many critics where there's something called as AI ethics that we need to follow. When people come, I'd say even do not post any of your pictures onto any of the tools to get something. Maybe how do you look like 100 years, 10 years elder, or 10 years younger. It is we who are feeding the data into it. There are some ethics and rules that we need to follow. If we cross over, and also the authenticity of the data is also playing a major role, right? About deepfake and other things comes, we need to apply. When we have a knowledge of what is happening around us, then you'll be able to justify between the correctness of data and the wrong data. All right. If there is no other question, Jay ma'am, can we close the meeting? Uh, we need to work more onto it. Like we always, you should not be in the consumer side. As you students, you are the greatest asset to to India. You need to be in the producing side. Most of us, we spend time on Instagram Reels, YouTube Shorts. That's all consumers. Focus your shift your mind from consuming to producers. And I'll tell around the world, Indians, you're very intelligent in comparison. But the way we invest our time plays a vital role. Thank you.
Session on machine learning and NLP. I'm sure we have learned a lot. We'll be applying in this current semester since we have NLP as well. The projects that we'll be doing on, it will be a very good touch while developing the projects. And I also thank all the students for your involvement and enthusiasm. And a big thank you for ma'am, Jaypreeta ma'am, for organizing this. So with that, we formally conclude this guest lecture. Wishing you all a great day ahead.
Okay. Thank you, Kiran. Thank you, Jay ma'am. Thank you all. God bless. Have a beautiful future.